This is part 5 of the review for the CFA on inverses and radical functions. And so what we're going to be looking at here is we're going to actually be looking at, let me adjust this a little bit. We're going to be looking at actually finding the inverse function. So we're going to be given a function and actually trying to find the inverse of that function. So what an inverse function is, like we talked about before, is when the domain and range switch. So the x and y essentially switch places. So when we're given a function and we're asked to find its inverse, that's exactly what we're going to do, is we're going to switch the x and the y. So f of x, as you all know, can be written as y. F of x is the same thing as y. It's just telling you, instead of writing it as y, it's writing it as a function of x, which is what a function is. A set of inputs, which is your x, your domain, and a set of outputs, which is your range, y. So in order to find the inverse of a function, what we're going to do is we're going to take that function and we're going to swap out the domain and range. So I'm going to rewrite this. I'm going to put the x where the y was and the y where the x was. X equals 4y minus 1. So again, all I've done is switch the x and y, which is what an inverse is. You switch the domain and the range. So now, looking at what I have, I'm going to go ahead and I'm going to solve for y, because for a function, you want to solve for y. So I'm going to take the 1, I'm going to add it to both sides. That leaves me with x plus 1 equals 4y. But I want to solve for y. I want to solve for 1y, not 4y. So I'm going to divide everything through by 4. And what that's going to give me is x over 4, which is 1/4 x, plus 1/4 equals y. Okay. And again, the other way you can write it is 1/4 x. You can write that this way. Plus 1/4 equals y. So this is a possibility, or you could write it this way. And that's how you find the inverse given a function. You switch the x and y and solve for y. So let's look at a second example. I'm going to go ahead and move up here. And let's look at example 5b. So we've got 5b, and 5b gives you f of x equals the cube root of x plus 2 plus 4. So I want to follow the same principle for this. I want to find the inverse of the function, which means I'm going to switch my x and y. So the first thing I want to do is I want to rewrite this with a y instead of an f of x, just so it's easier for us to make that switch. Okay. So I've rewritten the function, and all I've done is replace the f of x with y. Just a matter of terminology. So after we do that, now I want to solve and find the inverse. Or actually, not solve, but I want to find the inverse function. So I'm going to switch the x and the y. So I'm going to write this now as x equals cube root of y plus 2 plus 4. Once again, all I did was replace the f of x with y and then switch the x and y. Now I want to solve for y. So what we're going to do, I want to get this piece right here. That's the entire radical expression. I want to get that by itself. So I'm going to take this plus 4 and I'm going to subtract it. So that's going to give me x minus 4 on this side, and then cube root of y plus 2 on this side. So the question is now, what do I do next? Well, I want to solve for y. So what I'm trying to do is actually eliminate anything that I can as far as the radical signs to get this to be y equals. I'm trying to get all of the expressions to look like this, where y is isolated by itself. I can't do that when y is under the radical sign. So we're going to use the inverse operation. And the inverse operation of a cube root, which is the way you get rid of a cube root, is to cube it. The inverse operation of multiplication is division. The inverse operation of addition is subtraction. The inverse operation of cube root is cubed. So when I do this and I cube both sides, I'm going to end up, whoops, let me rewrite that here. I'm going to end up with x minus 4 cubed. And this is just going to be y plus 2. Okay? So when we get to this point, there's really two ways you can go. The first one is we can expand this and multiply it all the way out, where we have x minus 4 times x minus 4 times x minus 4. And then we solve all of that out, we simplify it, and then we add the 2. Or for our purposes here, just to save time, I'm just going to subtract 2 from both sides. So I'm going to have x minus 4 cubed minus 2 equals y. And that is going to be the way that I finish. Now, normally, like I said, you would expand this. And so I'm going to show you how to expand it, just so you know. So we're going to take this expansion here, and we're going to expand it out to x minus 4 times x minus 4 times x minus 4. I'm just going to take this expression and expand it. If I multiply these two together, these two factors, I'm going to end up getting x squared minus 8x plus 16. Because remember, it's this times this and this times this, and then this times this and this times this. And you would get x squared minus 8x plus 16. And then you're still left with that x minus 4. So once again, I would distribute. So it's going to be this one times all of this. So x cubed negative 8x squared, 16x. And now let's look at the second one. So I'm going to take negative 4, and I'm going to distribute it out. So negative 4x squared. And negative 4 times negative 8 is positive 32x. And negative 4 times 16 is negative 64. Apologize for running out of room. And then we're going to combine them. So when we combine these, I look at for all the x cubes, I have 1x cubed. So that's out. Then I have negative 8x squared, negative 4x squared. So that's going to give me a negative 12x squared. Cross those out. Then I have 16x and 32x. So that's going to give me positive 48x. Cross those out. And then I have negative 64. So that is going to be my final answer when I expand the x minus 4. Now, if you notice, what do we have after the x minus 4 cubed? We have a minus 2 on there. So I would actually rewrite it x cubed minus 12x squared plus 48x minus 66. And that would be my final answer. That is my inverse function. Equals y or equals f of x, however you want to write the inverse function. And that's how you do 5b. So let's look at the last one that we have, which is 5c. Go ahead and slide this up a little bit. And we'll look at 5c. Use the Sharpies a little bit better. So for 5c, we're finding we have f of x equals 2 times x plus 1 plus 4. And again, we're finding the inverse of the function. So what we're going to do is we're going to replace that f of x with y. So y equals 2 times x plus 1 plus 4. Once we've done this, we're going to go ahead and make our switch, because remember the inverse function, you switch the domain and range. So I'm going to switch the x and y. So this becomes x equals 2 times y plus 1 plus 4. And then it's just algebra from here. I'm going to distribute these out. So I have x equals 2y plus 2 plus 4. And I can combine the 2 and 4. So x equals 2y plus 6. So my next step, I'm going to have to move one of these over, and it's going to be the 6. So I'm going to subtract the 6, move it to this side. So I have x minus 6 equals 2y. And again, I want 1y, I don't want 2y, so I'm going to divide everything by 2. And we'll go up here and write the answer. So you get 1/2 x, which is the same as x over 2, minus 3, which is what 6 over 2 is, equals y. And that is your inverse function. So once again, to find the inverse function, you replace the f of x with y, you switch the x and y because that's the domain and range, and then you solve for y, and that gives you your inverse function.